Hello, everybody. I'm Dr. Surush Azizi, and today I want to talk about how to empirically estimate the expected rate of return for any assets or for any portfolio of different assets using two prominent asset pricing models that we have in finance. Number one, capital asset pricing model or CAPM, and number two, Fama and French three-factor model that we just call it FF3. So let's get started with capital asset pricing model or CAPM, which is the maybe the most famous financial model that we have. So the goal is this. The goal is that if somebody gives us an asset, any, for example, any stocks, Apple, Coca-Cola, Walmart, Google, Microsoft, starting from scratch, we want to be able to come up with estimated expected rate of return. So expected rate of return, when the word expected comes, it means it's about future. What we expect this stock in the future deliver. What amount of return we and all analysts expect this stock or asset to return in the future. What should be the starting point? So the starting point, to be honest, is a blank Excel file, and we are going to start from this. And we can focus on maybe three, four, five different stocks that we want to empirically uh, uh, just estimate their expected rate of return and a portfolio of these returns. So the very first thing that we want to do is to download data for these assets, and after that we can just calculate the growth and then keep going with different things. So uh, let's get started with this again. We are starting from absolutely blank page. So I'm going to start with start dates and then end dates. These are data, uh, the dates of the data that I want to download. So let's say that we want to get data for maybe 10 years. Maybe we want to get monthly data for 10 years. So I'm going to start from 2015, January 1st. And the end dates can be, for example, 2024, December 31st. So these are the start date and end date that we want to focus. And then let's say I want to focus on maybe a few different assets. Number one of them is I want to get data for Apple. So here, in order to download data on Microsoft Excel, we have to know the tickers of different companies. And if you don't know, you can easily search, but Apple is one of them. Microsoft MS FT is one of them. Let's say Tesla is one of them. And let's say Coca-Cola is one of them. And let's say what else? NVIDIA is another one. So let's say I want to get hold of NVIDIA. So I don't, for example, know that the ticker for NVIDIA. Again, whenever you don't know the ticker for a company, all you gotta do is to just search in the name of the company, for example, NVIDIA, and then ticker, and easily you can get the ticker for that. So for NVIDIA, the ticker is NVDA. So let me just do here maybe NVDA, and then so let me do in Tesla, Nvidia, and Coca-Cola. So we have five different companies here. And let me just do this. Let me write Apple twice. And I tell you why I'm writing this twice. The very first thing that I want to download, I want to do is to download the data for these five companies. How can we download data on Excel? Excel made it super easy for researchers to download data. All you gotta do is to just use equals stock history, and that's it. Stock history, and then you can just mention the ticker, and then you can just mention the start date and end date. We can also use, for example, a function like today to download data. Uh, that also works. However, I'm just using these fixed numbers. Uh, and then, so do we want daily, weekly, monthly? So for purpose of estimating expected return, in many cases, the typical it's a typical of industry to use monthly data. So I'm using monthly data, and then do I want header? No, I don't need that header. Then what do I want? For the first stock for Apple, I want dates and close. So I put 0 and 1, and I just hit enter, and it takes 2 seconds and it gives me all the data that I wanted. The monthly data from January 2015, end of the month. So it's like end of January 2015, end of February 2015, and all the way to end of December 2024. Wonderful. Then I'm going to do the same thing for Microsoft and everything else. So here again, equals stock history. My recommendation is that whenever you want to use a function in Excel, just type a few first letters and then double click on the stock, on the function. So in that case, you're sure that you haven't made a typo. So the stock is this, and then first date, and then end date, and I want monthly and no header. And now I don't need date, I just need close. So I just put this. And how about I just copy the formula and hit enter? So I got it for Microsoft. I paste this. I just change C to D, and I paste the data for Tesla, and I can do the same thing for here NVIDIA. I just make this change this C to E, and I get the data for NVIDIA. And lastly, I'm gonna do that for Coca-Cola. So I just change this to F, and boom, I got the data for all of these five countries, five companies, monthly data from January 2015 to December 2014. So I got 120 rows of data, yes, from row 5 to row 124, including 5 and 124. That means 120 uh, rows of data. So I'm going to call these sheets rather than sheet 1, maybe data. And then so here are all the data points that we have, and then how about I just copy everything and paste, open a new sheet, and then maybe here I want to paste them maybe here on cell A2 as values. Why as values? Because sometimes if you don't paste as values, you make any changes, then the the flow of your work might be get disrupted if you don't paste them as values. When you paste them as values, they are just as numbers. So I just paste them maybe as values here. And then now I'm able to change maybe this AAPL to dates. So the reason that I had AAPL twice because I wanted to mention that ticker. So these are, I would just call them raw data. And I don't like this dollar sign. I just want to get rid of them. So all I have to do is to just come here and then maybe change here to number. Boom. And we're all good. I got all the uh, numbers. After that, I want to calculate maybe a portfolio, maybe the growth for all of these. So I'm going to make another table. I'm going to leave the column G blank and just copy maybe the column dates and copy this here, paste it right over here. Then copy all the column names. So here I want to calculate the growth for each of these companies. Now, how can we calculate the growth when you have a variable that the value of that variable changes over time? There are the easiest way that makes sense is that you say, for example, equals the difference or how much it changed. So I can say, for example, cell B4 minus cell B3, and then divide it by the initial value, which is cell B3. I want to report all of these in as percentages. So how about I just multiply these by 100? In that case, we have all of these as percentages. And then all I have to do is to hit enter and it gives me the percentage growth. I can't calculate that for the first row. Why not? Because I don't have the data for the month before. So first month that I have this growth rate is the February 2015. And then I can just either drag this down or I could just also double click on this bottom right point, but the first one I'm going to just drag it down and you can see that it's calculated for everything. And then if I drag this to right, it calculates this for all other stocks. And then we can just double click here. So this growth rate is calculated for all of these months. Perfect. Now, in addition to all of these growth rates for all of the stocks that I have, I want to also calculate the expected rate of return, not only for these five stocks, but also I want to calculate the expected rate of return for my portfolio. How can I do that? How can I calculate that? First of all, the very first thing that we need is to calculate the portfolio. Imagine the portfolio is consist of so here I'm going to just call this portfolio and just imagine it's consist of, for example, uh, it can be different weights that I want. So uh, before doing that, let me just call this growth table or mm, return rate, yes, rate of return, rate of return. Mm, or rate of return, or just return rate, something like that. And then I would maybe I just put AAPL underscore R means like let's say uh return or so I know it's not just values. And of course, the value of stock cannot be negative, but here I know that these are returns, monthly returns for, so here I have portfolio return. So we can assume that we have different weights or equal weights. It doesn't matter, but I'm gonna assume that the weights are as follows. For example, Apple is so I'm gonna write on the maybe here Apple is, let's say, 20% of my portfolio is Apple. Let's say uh 15% of my portfolio is Microsoft, maybe 25% is Tesla, maybe 30% is Nvidia. How much did we get so far? 20, and then here 35, 40, 60, 90, and then Coca-Cola is going to be 10% of my portfolio. So these are the weights of different stocks, like respectively. So my portfolio return would be exactly like zero point 0.2 times. And these weights can be, for example, they can be extracted from somewhere else. For example, if you have a portfolio and you have maximized the Sharpe ratio, these weights can be just the weights that you calculated based on the maximum Sharpe ratio. But here I got zero point 0.2 times return of Apple plus 0.15 times return for Microsoft plus 0.25 times return for Tesla plus 0.30, 0.3 times return for Nvidia plus zero point 0.1 times return for Coca-Cola. Just make sure that these weights add up to one and then you're all good to go. So the return of portfolio is 8.15, yes. So essentially, this means that if I had $100 at the beginning, I would spend $20 on Apple, $15 Microsoft, $25 Tesla, $30 Nvidia, $10 on Coca-Cola. And these are the weights that I got for my portfolio, the growth return rate for my portfolio. Wonderful. So what did I do so far? So far, I started just from scratch, a blank Excel file, and I downloaded the monthly data and I downloaded the I calculated the growth rate for each individual asset and I calculated the growth rate for the portfolio. So here I can maybe name this sheet growth calculation or return, yeah, growth calc. calc. Okay. Now, so I got this one. Now let's see what's the next step. For that, I can go back to the Word file that we have here. So the famous CAPM formula that we have is right here. This is the super famous formula that we have for CAPM. Now I want to essentially estimate this model. Now, in this model, I have expected return of asset I. That's what I want to calculate. If I want to calculate that, I need everything on the right side. Let's see what we have on the right side. We have risk-free rate. Risk-free rate is the rate that the Federal Reserve of the United States announces. So, for example, the risk-free rates can be uh, the rate on treasury bills or the rate that we have for treasury bonds or something like that. And then we have beta I. And I'm going to talk about beta I in a second, but and also we need estimated uh, the excess rate for the market. So RM is the market return rate and estimate expected rates of return for the market minus RF. The whole thing is called excess return for market. So how can I get data for these things for RF, ERM minus RF, and then beta I? So in order to get beta I, we need to estimate this equation. As a matter of fact, so we are relying on the past data to get hold of beta I. But even if I'm relying on the past data, I need this RF and I need this RM minus RF. Is there any way that we can get hold of these risk-free rates and RM minus RF market return minus risk-free rate? Yes. There's this data set that's published by originally Fromm French came up with, and in order to get hold of that, all we need to do is to just all we need to do is to just Google Pharma French three-factor model. So we can easily do that. All I need to do is to let me do that, go to uh, my Google page, and all we have to do is to, uh, all I have to do is to just Google Pharma and French. Pharma and French data sets. If you Google Pharma and French data set, maybe the first website or maybe sometimes second website that comes up is this one. So the data set is mba.tuck.dartmouth.edu. And if you scroll down a little bit, so right here we are given this table, and on the first one, it says Pharma French three factors. So here I can just do CSV, and I can just download this CSV file for Pharma French three-factor model. So these are all downloadable. I can easily download this data set, and if I download this, so it said a zipped file. You gotta unzip this file. Let's unzip this, and then if you unzip this, you can easily open that in Excel. How can we open this in Excel? Just all you gotta do is to right click on this. So right click on Mac is control click. So right click and then go to open with, and then open that with Excel. So I can easily open this data set in Excel. Let's take a look at this data set. Let's see what I got here. In this data set, I can see that we have four different columns. First of all, the data starts from 1926, July 1926, and it goes all the way to current time. So all the way to 2025, and the last row that they have is September 2029, 2000, September 2025. After reporting the data, the monthly data, they also have annual data. So both monthly and annual data are in this table. So that's the dates that they have. So first four digits are the year, and then the last for two digits are the month. Now we have four columns here. Column number one is market minus RF. That's exactly RM minus RF that we have. And then we have SMB, HML, and RF. SMB stands for small minus big. So based on Froment French three-factor model, this small minus big is one of the determinants of return of the expected return of the data. And HML is high minus low. It refers to book value, book to market value for different stocks. So again, based on Froment French three-factor model, this is the third factor that impacts expected return for any stocks. And last column is the risk-free rate. So I'm gonna just go down and find the rows that I actually need. So my data includes data from January 2015. So I'm gonna go all the way to January 15 and select or highlight everything to December 2024. Now I selected everything. Good. Now I'm going to go back to the Excel file that I have. So let's go back to the Excel file. Now here I'm going to open up a new tab. Let's call this tab CAPM. And let me paste that on cell A3. So let's leave first two rows as blank and paste it on A3. So on A3, I pasted everything. And how about we paste also maybe these titles? So I'm going to go back here, go back all the way up. And let's copy these column titles and I'm gonna how we paste it right here. So here is Pharma and French data sets. So I got the Pharma and French data set. That's wonderful. Now, what else do I need? I need to copy and paste the data that I created here on growth. Let me copy this and let's leave column F blank and paste it right here. Oh, when you paste it, make sure that you paste it as values. If you don't paste it as values, you're going to get these problems like division by zero. So on Mac, I do Command Z. Command Z reverses what you did at the very end, the very last action that you did. On Paste Special, I paste them as values. Wonderful. So this column, this table is called return rates. Great. Now, I got the return rates here from February 2015. Since I don't have data for January, I can just delete this first row here because I don't have data here. I don't need data over here. I got these two. Now, let's see what the goal is. So, the goal is to get hold of beta i's. If I get hold of beta i's, I can go to this CAPM equation and I can rely on the historical data. If I have beta I can plug them in here and calculate expected rate of return. Now, so I must calculate beta i's, and how can we do this? If I have Ri minus Rf and a Rm minus Rf, then that's going to be easy. That would be easy. I can just regress or somehow get hold of this beta I by doing this linear relationship. So I have Rm minus Rf from a French data set, but I do need this Ri minus Rf. What is Ri? RI is the return rate that I just calculated. What is RF is risk-free rate. So I have return rates, but I have to deduct these RF from them to get hold of excess return rates. So here, let's leave column N blank, and then let me just copy these, maybe uh, the date one more time, have it here, copy the column titles, have them here. We call this column excess return rates, excess return, or rate of return, or return rates. Uh, Now, in order to calculate this ERR, so I have to say, I'm going to say here, for example, for AAPL underscore R equals this guy minus this RF. And I can hit enter and drag it down and calculate that. However, if you just do this, then when you scroll this to right, that's not going to work well. Why not? Because when you scroll this to right, as formula here, you're saying Microsoft, but also this one, the deduction part also moves to left. So, for example, for Tesla, here I got negative uh 4,000. So here essentially I'm saying that the Tesla rate minus dates, which doesn't make any sense. Negative 42,036. So here I have to uh just delete this with Command Z. I want to fix the column E here. I don't, when I'm dragging this to right, I want column H to be dragged to right, but not column E. So I need to fix column E. In Excel, you can easily fix each column with putting a dollar sign before the column rates or the row rate if you want to, row name if you want to fix the row. Here I want to fix the column, so I put dollar sign before the column. And now I can easily just move this to right, and beautiful. So this one is just Microsoft minus risk-free rate. That's good. That's very good. And then calculate this for all the columns, and beautiful. So I got all the excess rates, excess return rates, and then these are essentially RI minus, if I wanted to just mention them here in mathematical format, these are RI minus RF. And here I got this one, and I have R market rate minus RF. So this is essentially RM minus RF. I have this, and that helps a lot. So let's see. So now we downloaded the data from Palm and French data set. We calculated all the growth data, and then we can create something called security characteristic line, or SCL. What is this security characteristic line? Security characteristic line is the graph of these excess return for different securities versus excess return for the market. So excess return for securities would be on vertical axis, and excess return for the market would be on horizontal axis. How can we do this? How can we create security characteristic line, which is next step? So here, all I have to do select two columns at the same time. Maybe here I want to just select this column first. So I'm going to select this column. Now, let's hold the command button down on PC, control on Mac command button down, and select this. So as you can see, now both columns are highlighted. Wonderful. Now all I have to do is to go right here to inserts and go to charts and insert a scatter plot. I can easily do this, and here my vertical axis is x-10 for Apple and my horizontal axis is x-10 for the market. So let me call this graph security characteristic line SCL for AAPL. And I can just move this down maybe so it doesn't just cover my data points. And now that I have this data, I can make it a little bit bigger. So vertical axis is excess return for Apple. Horizontal axis is excess return for the market. Now that we have all of these, we can just easily, uh, if I wanted, also I could just do add chart elements. I'm going to just do that only for Apple, axis title, primary, horizontal. Uh, it's excess return for markets. Excess return for markets. And my vertical axis is, so I go to axis title, primary vertical, and I call that excess return. Excess means excess to risk-free rates. Excess return for Apple, AAPL. Wonderful. Now I got this. I can just easily add this security characteristic line to this graph, a line that uh, is closest line that to these data points. How can we do this? First, you're going to click on one of these points. As soon as you click on one of these points, you see some of them are selected. Yes. Then you can just right click. Again, on Mac, that means control click. And just say, uh, so right now it doesn't say anything, but let me just do it one more time. So here, if I right click, format, select chart type format. So let me see. Okay, right click and yeah, right here, add trend line. I click on add trend line. As soon as I click on add trend line, Excel adds this trend line for me. Then I can say display equation on chart and display R squared value on chart. Here I got both of these. So let me just make this bigger. Now I got the equation for this. This is the equation for this line, SCL line. Y equals 1.18x plus 0.7927, and then r squared is 0.4615. Before going any further, let me explain the meaning, the interpretation of these items. That 1.18 is the beta for Apple. What is exactly that beta 1.18? So essentially, it means that if markets, if excess return for market increases, for example, 1%, then the excess return for Apple is expected to increase 1.18%. So if your independent variable increases 1%, if it goes up 1 unit, then this one, excess return for Apple, is expected to go up 1.18%. It doesn't necessarily mean that in future this relationship holds. We don't know about future. If we knew future, we could just easily become billionaires. But I'm talking about expected return, yes. So here, that's the interpretation of beta. How about interpretation of alpha? Alpha, that we got that as 0.79, it means that this model, Apple, in the past 10 years, on average, each month, outperformed the predictions of CAPM by 0.79, just around 0.8% a month. That's huge number. So every single month, Apple, as a matter of fact, in the past 10 years, outperformed the prediction of CAPM model by 0.8% per month. So per year, you gotta like roughly multiply it by 12. And R squared, which means, which we got it as 0.46, that means essentially 46% of variation in your dependent variable, which is here excess return in Apple, can be explained by variation changes in your X variable, your independent variable, which here is excess return for the market. So we got that for Apple, and so now we can just move to the next one and next one and next one. I'm gonna do the rest of them a little bit quicker, but every single time, all we have to do is to select this one and then select uh, this one. So here I have to just let me select this first. Go to the second column here. Hold down the control command button and then select this one. And then make sure that number of rows that you're selecting for these two columns are exactly the same. Otherwise, you're going to get error. I got this from Microsoft. I'm going to put it right here. So let me change the name. SCL for MSFT. And let me click on points. So let me see if I do right click. So click on any of these points. Yeah, you got to hold the right click. You got to do right click, not just click. I was doing that wrong. Wrong. Add trend line, display equation, and R squared on charts. So I got that for Microsoft. So beta for Microsoft is like zero point 0.9 based on this model. And then let me go to the third one, which is Tesla. So let me choose this market excess return. And then I go here. I do hold down the command button and then I choose Tesla. Great. Insert. Then one more time. Oops, I did something wrong. Let me do insert. Okay, this is what I want. So this is my, let me just put that maybe here. So this is for Tesla. Uh, SCL for Tesla, TSLA. Click, right click, add trend line, display equation and R squared. And then, so as you can see, beta for Tesla is really high, 1.8185. And then I'm going to do this for next one, which is NVIDIA. So hold down the command button. Oops. So for NVIDIA, insert scatter plots. So this is for NVIDIA SCL for NVDA. Click, right click, add trend line, display equation, display R squared. Beta for NVIDIA is 1.7. Nice. Then I just choose this one more time and I select everything for Coca-Cola. Insert the scatter plots. Let me move that below Tesla. Call that SCL for Coca-Cola. Right click, add trend line, display equation and R squared on the chart. So beta for this one is really low. It means if market excess return increases by 1%, uh, excess return for Coca-Cola increases by uh, almost 0.5%, like 0.48. And one last time. So for portfolio is exactly the same. No, nothing is different. First you select that and then you select the portfolio return and then insert and that's it. So here I'm going to just move this to right here. So I know that this is SCL for portfolio. Portfolio. And click, right click, add trend line, display equation and R squared. And I'm gonna move them up here. Perfect. I got everything. Now, is there any way that I can double check if I have calculated all of these betas correctly? Because if I do this incorrectly, my expected return would be incorrect. Yes, there is a very easy method that we can do this. So we can use something called equals. let me go here, equals line st. And when you do this equals line st, essentially you can say select your y's and your x's, and it gives you both beta and alpha. So if, for example, first you gotta choose the y that we have. So let me see, the y that here we have is this. I'm gonna select this all the way to here and put a comma and then select all the x's that you have. So here we select this and boom, it gives me these numbers. Let's just check if these numbers are correct. 1.1799 for beta, 1.18, which is essentially the same thing. Perfect. I got that one. For beta, I got 0.7927. 0.7927. Absolutely exactly the same numbers. That means I've done everything correctly. So this one is beta, this one is alpha. And here I got then these six uh, names. So I'm going to copy them and then paste them right here. Paste them as vertically. Yes, paste special and then transpose. So I wanted to paste them vertically. So I did it for Apple. For the rest of them, I can just copy this formula and then change that P2, maybe next column is Q. And I got this 0.90. Let me see. 0.9026. Perfect. 1.118. 1.118. Exactly correct. Then, so I did PQ. Let me do R. And then one more time, I pasted R, S. Then T. And O, OPQRSTU. Portfolio, I'm going to do U. Let me check the portfolio as well. 1.39, 2.04. For portfolio, 1.39, 2.04. Absolutely the same. That means I have done everything correctly for this CAPM. I got all these betas. Perfect. Now that I got all of these betas, I can easily calculate expected rate of return. So let me just create one more tab here. I call this maybe final delivery, final results. Yes, final reports, whatever you want to call it. Now, here, I want to copy these and then paste them maybe as values, paste special values right here. So here, this is the cap M beta. So I'm going to call this beta cap M because later on we are going to have beta for FF3 as well. Now, here I want to calculate expected rate of return, E of expected rate of return based on cap M. Yes. Now, how can we move from beta? So we used historical data to get hold of beta. Now, from that, how can we estimate expected rate of return. So this is the equation for CAPM. Now, for CAPM, uh, we got beta. ERM minus RF also comes from historical data. Now, historical data, if we just focus on years after 1963, which we started collecting data in a modern way, we can see that the average market risk premium, this ERM minus RF is called market risk premium. That averages to 7.8. And if you don't believe me, different researchers usually report different numbers for this. But we can just go to the annual data for this Farman French three-factor model. And I go to year 1963, and if I select everything to end of 2024, you can say right here the average is 7.766, yes, or roughly 7.8. So based on Farman French data set from 1963, which is the first year we started collecting data in a modern way, to end of 2024, this is 7.78, yes, or 7.8, just uh, so I'm gonna replace this ERM minus ERF by this 7.8. And then right now, risk-free rate is almost 4.1%. It changes every day, but right now is around 4.1%. So I'm gonna do this. Here, I'm gonna use this equation. Yes. Take a look at this equation. 4.1 plus beta times 7.8. Now I go to my Excel data set, and here this would be equals 4.1 plus this times 7.8. And everything is reported as percentage, and beta is 1.17 here, for example. All I have to do is hit enter and drag this down. Let's see what we got. So here, based on CAPM, CAPM predicts that CAPM tells us that we expect Apple to have 13.3% return in future. Yes. Now, again, this is just expectations. It doesn't mean that it's going to be 13.3. If I knew this, I would be, I would definitely be a billionaire. However, this is super helpful because we are going to build our expectations, and we can use that for many, many different situations in finance. For example, in corporate finance, we can use this as required rate of return. So in corporate finance, we use this as required rate of return, and also in different branches of finance, like calculating present value, different things. You can use this. You can use this expected rate of return, and not only for stocks, for any other assets, for even for projects, you can calculate this expected rate of return. So we just finished calculating this expected rate of return based on CAPM. Next model that we have is Farman French three-factor model. How can we do that? This. So let's talk about the theory first. So Farman French three-factor model starts very similar to the CAPM. But in addition to that, it has two more terms, two more expressions. One of them is this RSMB, and another one is return HML. SMB stands for small minus big. So former French claimed that small companies on average have higher return than big companies. And companies with high book to market value outperforms companies with low book to market values. So they said that estimation of this expected rate of return should not rely only on market risk premium, but also we should include two more terms. One term is this return for small minus big companies, and then another one, return for high minus low book to market ratios. Now, so here we got three different betas. One beta for markets, one beta for SMB, one beta for HML. So I can, for example, go here and just write these three names. Beta FF3. Uh, so here we have three betas. Maybe I call this beta for beta underscore M underscore FF3. So I know that, and this one is going to be beta underscore SMB, small minus big, underscore FF3. And then here I have uh, beta underscore uh, high minus low, HML underscore FF3. Now, we got all and then here is going to be expected rate of return based on FF3. Great. Now, how can we get hold of these betas? Let me go back to the equation. The equation that we have is right here. Yes. Now again, we have to use something called regression here. Now, regression essentially here I'm gonna have a formula like this. However, this formula is going to have two more terms. The two more terms that we have, they are, so here the formula would be something like this. I'm going to rely on historical data to get hold of these three beta IM and then beta ISMB and beta HML. But we have to use something called multiple regression. We can't do the just this scatter plot and get the beta, or we can't use just this simple uh, line ST that we had. We have to use regression. In order to use regression, we got to make sure that we have that. So it's add in Excel, and the way that you can have it, you can see if you have it or not. Go to tab data and see if you have this data analysis. If you don't have this data analysis, you can add it. It comes with Excel, but you have to add it to the items you have. So on Mac, you can go to Analysis Tools and then click on Analysis Tool Pack. Just check that box. And if you do that, this data analysis appears here. And then here, when you have this, you can click on data analysis and you can see this window and you can click on regression. How about PC? How can I find that on PC? On PC, it's a little bit more complicated. On PC, you gotta go to Files and then so you go to File and after File, you have to go to Options and after Options, you go to Add-ins and in add-ins, essentially you gotta go to analysis tool pack and after analysis tool pack you click on select the box and you click on go. So these are different paths that you have to do. If only you have to do this at the very first time after adding the option of data analysis, then you're all set. You don't have to do it every single time, but this is the way you have to do it. When you do it, then you are going to have data analysis right there. So I can go back to my data and then I start with this data analysis. And then here I get this regression. So I click on regression. Now this is the page that shows up. So I have input Y range and input X range and a bunch of other things. So one more time, the things that the equation that I want to do is this. The equation on the left side, I want to have essentially Ri minus Rf, and very similar to this equation that I had over here. But in addition to Rm minus Rf, I have two more terms. What are those two more terms? Yes, RSMB and RHML. Now, for that purpose, in my Excel file, first of all, let me just copy this rows. We must do this and paste it right here. And also for my um, dependent variable, there should not be any gap between the column titles and the data that we have. So that's why I did this. And after that, I can just go to data analysis, click on regression. Very first thing you want to do is input Y range. So Y range would be Apple access return, including the title. So include the title for sure. And after that, input X range. So X range would be all three of these. Do not include risk-free, just the first three columns that you have. And scroll all the way down. Make sure that you have chosen the label. Therefore, check this box, which is label. And now Excel gives you the option to either create the data right in this page, which is going to be really messy, or see the data on a new worksheet. I prefer that one. I call this maybe AAPL underscore FF3. Yes. So that's going to be the name of the new sheet. So as soon as I click on this OK, that sheet pops up. Yeah, as you can see right here. And now we can talk about different meanings of this. We need only this column and not even intercept. The intercept is again alpha. These are the three betas that we have, and I'm gonna just copy and paste these three in a second. But p-value essentially, if it is less than 0.05, it means it's significant. We have also r squared. It means like 52%, 53% of variation in dependent variable is explained by independent variables. But the thing I do need is these three numbers. So on coefficients, not for the intercept, these three. So I'm going to just copy them, go to my final report, and then I want to paste them horizontally. So here I right click, paste special, and transpose. Boom, I did that for Apple. After that, all I have to do is go here, do the data analysis and regression one more time, and then change. I don't even have to change everything. Just change this P to Q and then this peak to Q as well. And then maybe change this name as well. I want this, for example, to be MSFT underscore FF3, and then click on OK. Boom, I got the data for Microsoft. So I select these three numbers, I go to final report, and I paste it right here, transpose. Perfect. Now that I did these two, I go back to CAPM one more time, data analysis, regression, PQR. I change this Q to R and then change this to TSLA and click on OK. I'm going Copy these three numbers and paste them right here. I got this for, let me now do it for next one, which is NVDA, R, change that R to S, change this R to S as well. And then here, NVDA, click on OK. I'll get these three, paste them in final reports, paste special values. Oops, Control Z, paste special transpose, not values. Okay, good. Go to CAPM. One more time, data analysis, regression. I did S. I'm going to do T for Coca-Cola. That's the column T. And then here I change this to KO. Click on OK. I get these three numbers. Paste them here on final report. Paste transpose. One last time, go to CAPM. Do the same thing for portfolio. So regression, T and RSTU. And here I call it portfolio. Portfolio. And click on OK. Boom, I got these numbers. Copy that, paste them right here. So now all I have to do is to calculate this expected rate of return based on form of French three-factor model. Now again, based on historical values, this ERS expected return of small minus big is 2.2%. And expected return for HML is 3.7%. Again, these numbers come from historical data. So if I have all of these, then I can form expected return based on the numbers that they have here. So, and then if you don't even, if you want, you can also copy and paste this formula right here. It doesn't hurt, to be honest. We can just put them like, let's say for FF3, just paste this here. And then for CAPM, I'm going to paste the formula for CAPM here. So we know that where we got those things. And we also can make sure that we don't make a mistake. Okay. Now that I got all of these, I can easily go here equals 4.1 plus, then, so here I have this guy times 7.8 plus this times 2.2 plus this times 7.3, 3.7, 3.7. And I hit enter and I drag this down. Awesome. Let's see what we got. Here, based on CAPM, we expect Apple to have 13.3% return. Our expected rate of return based on CAPM for Microsoft is 11.1. For Tesla is 18.56. For Nvidia is 17.3. For Coca-Cola is 7.8. For the whole portfolio, with the weights that we mentioned at the beginning, is 14.97, around 15% return. Based on Farman French three-factor model, It's 11.3% for Apple, 9.089 for Microsoft, 15.33 for Tesla, 13.93 for Nvidia, 8.28 for Coca-Cola, and 12.47% for portfolio. So this is the way that you can use CAPM and Farman French three-factor model to estimate expected rate of return for any stock that you want. And I hope you enjoyed this video. Thank you very much for listening. Have a wonderful time.